In this part of 3.3, we're going to look at slopes again, but now we're going to look at the relationship between the slopes of parallel lines and the relationship between the slopes of perpendicular lines. Some of you may remember this, but if you look at the slopes of perpendicular lines, those are going to be opposite reciprocals, meaning if one of them has a slope of, let's say, 3/2, the other line is going to have a slope that's opposite to that. Well, opposite of positive is going to be negative, and the reciprocal means flip the fraction, so it's going to have a slope of -2/3. That's just one example of slopes of perpendicular lines. Now when you go to parallel lines, being they never touch and they're kind of always going in that, I think, of same direction, their slopes are going to be equal. So if one has a slope of 2/3, the other one's going to have a slope of 2/3. Now we're going to cross a problem like this. I want to know if these lines, that would be line P and line N, are they parallel, are they perpendicular, are they neither? And all that give you is 2 points on each of those lines. So the first thing I want to do is, well, let's figure out the slopes. Because you could graph this, yes, and in many cases you'd be able to say, yep, they look parallel, or no, they don't, I can tell they're intersecting. But at the same time, they may look parallel, but they may not actually be, because they may intersect at a point that's really far off your graph. So if we look at their slopes, that's going to give us all the information we need. So I'm going to look at, now remember, M stands for slope, so the slope of line P, and I'm just going to do all of my calculations right here. I'm going to go back to my slope formula, and I'm going to take -3, I'm going to subtract the 2. So there's my rise over, now calculate my run. Subtract my x values. And I end up with -5 halves is the slope of line P. Now I need to find the slope, remember M is slope, of line N. And here, do the same thing. I'm going to subtract my y values. So 10 minus 5 over -3 minus -1. And here I end up with the slope of 5 over -2. Now some of you are going to look at this and say, well, those slopes aren't equal because in the top one the slope is -5 over 2, and in the bottom one the slope is 5 over -2. But really, both of those are saying slope of -5 halves. So yes, these two lines are going to be parallel. Now, had one of them been positive and one of them been negative, then you would have been looking at neither. And if I had taken, let's just say, take the green one, if I would flip it, so now it's 2/5, and leave it positive, then we would have had perpendicular. On this one, I want to do a little bit of graphing. And notice we want to graph a line, and we want our line to go through this point. So before I go any farther, since I know it has to go through 4, 3, I'm going to plot that point. 1, 2, 3, 4, 1, 2, 3. There's my point 4, 3. I know my line has to go through that point. But then I want my graph, or my line, I want it to be perpendicular to this line AB. And I know line AB goes through -3, 4, and 1, 9. Now some people want to graph that, and you could, and maybe I should. Let me take this line, -3, 4. So there's -3, 4, and 1, 9, 1, 9. Now I can make a line go through there. And I need my line, remember this time now, I need it to be perpendicular to the black line, and it has to go through the blue point. Now we can't just sketch it in there and hope for the best. So what I want to do is, I want to calculate the slope of my black line. You have multiple ways to do it. You could do like I did the first time, where I just count up and over, or we can use our slope formula. So I'm going to do the slope of line AB. That's supposed to be a little arrow there. And what I need to do is I need to do 9 minus 4, and I need to do 1 minus -3. So I have a slope of 5/4. Therefore, the slope of my line, so I'm going to put slope of perpendicular line, is going to have to be -4/5. Well, that tells me direction where to go from any point that's on my line. I know the blue point is on my line, so what I'm going to do is I'm going to go up 4. 1, 2, 3, 4. And then being it's negative, I'm going to have to go back to the left. 1, 2, 3, 4, and 5. So here's going to be another point on my line. Now, I could also go down 4, 1, 2, 3, 4, and to the right 5, 1, 2, 3, 4, 5. So here's another point that will be on my line. And now I just need to connect the dots. So I'll make my line, go through those 3 points. I'll extend it a little bit for us. Why don't I change the color to green? Maybe not. I suppose I have to do this. Hold on. Now I can change the color to green. So there's my perpendicular line. There you go. And when you look at it, being it's on the coordinate grid, they should look perpendicular. Now if you sketched your own, it may not look perpendicular because you may not be perfect with what you do. But I have now graphed a line that's perpendicular to line AB. And that's going to conclude our lesson on looking at the slopes of parallel and perpendicular lines.